to extend thank you so much to the legend one, to the inventor, to the genius one. The name is the Hemming distance. Hemming distance is like this, guys. You look at this. This is the reason why I want to show to you how to tune. This is not really easy, okay, guys? See? Hi, welcome to Rifki the Cyber. This is the part 2 for the Inmarsat. And I promise it to you, this is the part 2 of the 3. There will be the 3 sequels in this case, guys. In the part 2, I just focus on the frequency tuning in this case, guys. But before we go to the garage, and we will do some tuning of the frequency, because it's not easy, guys. It's not like click, 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 it's very, very narrow beam and narrow band in this case. The thing is, I would like to say, we need to extend thank you so much to the legend one, to the inventor, to the genius one. The name is Mr. Andrew Viterbi. He's also the co-founder of the Qualcomm. So, with this invention of the algorithm, the Viterbi algorithm, we can enjoy the telecommunications data exchange, guys. Because the algorithm of the Viterbi is actually do the bit corrections. Can you imagine, guys, the data that traveling from the 36,000 kilometers above the sky, it will be prone to some corruptions, corrupted data, some error of the data. So with the Viterbi, this is just very abbreviated, shallow or narrow analogy. If they want to say yes, it will be say yes, yes, yes. So when we arrive, if the 2 yes is corrupted, at least we know that it say yes in this case. Or if sending Alpha Yankee and is arrive in the Earth is like Phi Yang, that means it will be Alpha Yankee. It will be fixed by the algorithm of the Viterbi. So it's using the convolutional. Every 1 bit, it will be sending 2 bit. And also using the using the state shift register just for correlated. And also it will be using the generator 7.5 octal. So for example, if from the satellite sending 1011, it will be arrive in the Earth. It will be sending like 111, 00001 in this case. So it's like using the state and then using the input. It will be SOR and SOR again. We will get the 2 bits. And after that, prepare for the next output, next state. And then it will be SOR again with the next input until we will get all these digits from this one and become this one. And when it arrive in the Earth, the Viterbi algorithm will not just trust like that. This is the bit. No, it will check. It will check again almost with the same steps and finding which one is the most shortest, the Hemming distance. Hemming distance is like this, guys. If the actual bit is 10 and we receive 11, that means there is a 1 mistake in the bit, right? That means 1 distance. If the bit is 11 and arrive in the Earth is 00, that means there are 2 bits is wrong, right? That means the Hemming distance is 2. It's something like that, guys. So it will be do like this again, and then after that, after there are some 4 input, collected again, decode again, and it will be traced back using the trellis path, which one is the shortest distance, and we will get the actual message. I will not tell these details in this video. But again, me personally, I would like to thanks to the Mr. Andrew Viterbi. I pray, hopefully you will always in the good shape. You are always health, your contribution and the breakthrough of the telecommunications. And also I know that you are the co-developer of the Qualcomm, of the CDMA. You are also the co-founder of the Qualcomm. So allow me to say this, grateful to you. Grazie, signor Viterbi. Thank you so much, Mr. Viterbi. Okay, guys. Let's go to my chamber. Sorry, I mean go to my garage and we will tuning the Inmarsat there. Okay, guys? I think you already watched, right? The video in the part 1. It's very essential, it's very critical, and it's very important for you to prepare this kind of Inmarsat observations in this case, okay? And in this part 2, I would like to emphasize only how to tune this one, but definitely you need to watch the previous one in the part 1, okay? Because also in the part 1, I was enable also the UDP and some particular port for the UDP that's going to be used in the part 3 later on, okay guys? So now we are going to open the SatDump. I think I was spill with you in the part 1 about the decimations, etc. But okay, maybe some of them I will just to explain it again. And I show to you the GitHub link that is actually quite helping me for this one, for the... Okay, now I need to refresh and then I need to choose my RTL in this case, which is I already mentioned it to you before. And the decimation is actually for the zoom, right? I will just unclick the bias T and we will choose this one. From where I get this? Look at my first part 1 video about this one, okay? And I'm going to choose the nearly the 2 million sampling, 250 kps. The default one won't be enough for this one. And this is the LNA low noise amplifier, which is built inside of that antenna. If you look in the other side, you can see in the right side, right? And we will power that one with this bias T. But before that, I'm just going to start this one first. Okay, now I'm going to power on that one with this bias T. So I explained to you in the part 1 the concepts, almost all the same spirit like the power over the Ethernet, but this is power over the RTL, for power over the SDR itself to transmit the 5 blocking to power on the LNA inside of that antenna. Okay, guys. Okay, I will click one, the magic will come, boom. Okay. I will just this is actually can be 49, but I will just use the 44 because sometimes the big one doesn't mean it will be really good, because sometimes it will be mixed also with the noise as well. Okay, guys. Okay, now what I'm going to do, I'm going to click the decimations. Okay, I will just make the decimation like 4 maybe. We need to SatDump to connect to the 4. I think because of the zoom itself, decimation is zoom, the target frequency that we want to choose, I will just make it 1 again, this one. This one is actually shifted to that one. Okay, where is it? Okay, 5396. Okay, no problem. We will just stop this. Put 5 here. Bias T. Okay, this one, right, guys? Okay, so now what I'm gonna do, I'm going to tune this one, guys. Okay, guys? So I tune this one. First, I will just tune this frequency in this case. Okay, I will just make it, for example, this one. Currently, the frequency is around here. Okay, guys. So what I'm gonna do, I'm going to tune this. What frequency this one? Okay. Okay. Now what I'm going to do is I'm going to jump, going up, up, up. You look at this, up, 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 up. Okay. Now you need to switch on. This is the time for you to switch on this one. Processing. Inmarsat. You can look here and you can make it as a favorite like this, Inmarsat. And don't forget to switch on the DC blocking. And then we're just going to start this, okay? Okay, now I'm going to switch on a little bit. Okay, this is near here. Let me stop this. Let me check if I make decimation 5 is sufficient or not. Okay. Okay. Let's continue again. So the zoom is really obvious, right? If I put it above like this, right? And right now you can see this BPSK, the modulator. This is also the art or the technique itself. If the constellation is become separate like a 2 dots, that means you are in the business in this case, okay? Okay, maybe I'm too much here. Okay, let's do this very slow. Okay, this is already become changing. Let me make it small again. Okay, now I'm playing with this every 10 hertz in this case. Okay, guys? It's okay. 10 hertz. Maybe I will do like this. Okay, now it's become like this. Okay. Okay, the SNR still is already increased in this case. I'm going to slowly make it up a little bit. Okay, SNR still not okay. You look at this. Why? This is the reason why I want to show it to you how to tune. This is not really easy. Okay, guys. Okay, I think I'm not get around 5 around this one. Let me shift to this one. Let's check this one. Okay, guys. Maybe too big. I will just do like this. Now increase with the 10. Okay, this is a bit changing. Let's see. I'm not promising anything. Let's see for this one. SNR is moving, but constellation still one. Okay, I think I failed from this one. Okay, I think, guys, I'm going to check this one first. Okay, guys? I think we not yet check this one. Let me check this one. I think we just passed through this one, right? Let me check to this one first. Let me check. That means I need to going down here a little bit. Okay, the constellation is changing now. Let me check. I'm going to play with this now. SNR is increase. Okay, let's check. Is it? Wait, before it was increase around here. Wait. Changing here. Maybe per 10 things here. Okay, I will just shift going down and going up again, and slowly 10 Hertz increase. Okay, it's changing now. Okay, it's increase. Let's check. I told you this is very, very narrow, right? And I want to dedicate this. I told you this is not really easy, right, guys? Let me do like this. Sometimes the magic is start like this. See? Sometimes you need also to play. I will just stop it again. Okay. No need. Okay, this is okay. See? If you already got this correlator here, that means you already get the package from this one. See? I need to blur this one. Okay? Okay. So, your homework is, whatever it is the frequency that you're going to put it here, you need to write it down. You need to record this one. What frequency this one. Okay? It's very important, guys. Because the collections of the frequency that we already have, we will use it later in the part 3, the final part, when we are using the Wireshark. Now what I'm going to do, I'm going to stop this and we will tune again another, we will find another one, okay? Okay, I will shift again. Okay, we will collect this one. We will collect this one, okay, guys? We will collect this one. What is the frequency here? I don't know if we can get hopefully strong enough. Let's check. Yeah, this is okay. In order for me to shift this, we need to increase this one, right? Okay? Make it, this is 5, guys. So the picture will be zoom, obviously, right? Okay. Shift it. Shift a little bit like this. Okay, now it's time for me to DC blocking. Okay, start. Okay, now we switch on. And let's check with this one. Okay, my vitamin alarm is on. Okay, this is become smaller. Hopefully it will be evolved to the... But SNR is not increased, right? No SNR. Okay, now let's play with this. Okay, SNR is moving now. Make it going down. Okay, going up again. Going up. Going up. I told you this is not easy. Some people when make the video is... okay. Become 2. Okay, this one. We are waiting the correlation. Hopefully correlation will be pop up. Usually this one first will be boom, boom. And then correlation will be pop up. Let's check. Do we get something from this one? Okay. Correlator up. Filter, and we get also already the package, right? So you check, this is move, SNR increase. When this is already separate, become 2 constellations. And then correlator on, that means you are in the business already. Okay, so collect again this one, guys. Collect again the frequency itself. Okay, guys, you need to collect this frequency again. And put it also later in your, what do you call this? For our own part 3 later, guys. So this is how we tuning the frequency of Inmarsat. As I always say in my other previous video, keep learning and stay humble.